Okay. Ito, si Ralph po tsaka si JP, they showed you ano ba yung mga steps that you actually have to execute whenever you are trying to design an experiment for a particular project. Yun po, framed around the scientific method, best practices, how, things to watch out for in terms of controlled, independent variables, and then yung effects of dependent variables, matrix effects, or yung extraneous variable na tinatawag. Nagkakaiba-iba lang sila ng terms, pero yun lang din po yung parang tatlong klase lang din po yung mga variables na ating kino-consider. Pero ang pinakamalaking question po sa atin is, once we reach the point of nakapag-ideate na tayo, alam na natin yung research question natin, alam na natin yung specific objective of the experiment, and na-identify na natin kung ano ba yung mga techniques or yung mga techniques na i-implement natin. Ang question po is, paano tayo mag-start? Paano natin sisimulan yung research? Ano yung first set of experiments na gagawin natin? At paano ba natin may ensure na yung choice natin ng experiments is not limiting the possibility of us getting to the right outcome? So, yung pong i-introduce ko po sa inyo are two fairly new approaches to designing experiments or approaching or starting an experimental campaign in two different situations po. Yung una, alam mo na yung approach, but then you have limited resources. So how can you actually maximize the generation of data with as much as possible, like a minimum number of experiments? So yun po yung una kong ibibigay sa inyo, yung sa concept ng design of experiment. Yung pangalawa naman pong topic na i-discuss ko sa inyo ngayon is, paano kung if you have like a big research question, you have some hints kung ano ba yung mga potential variables involved that pwede mong i-explore, i-investigate via experimentation, pero you don't know where to start kasi walang established na data. Paano ba yon? Ito naman po yung tinatawag natin na brute force approach, yung knockdown approach, but at the same time, meron na pong mga it's getting it's getting kumbaga nauuso na po siya ngayon in the sense that meron tayong tinatawag na accelerated serendipity. So paano ba natin i-accelerate or paano natin papataasin yung probability that we would run into happy accident? How do we on purpose push ourselves to run into some very nice discoveries kahit hindi sobrang well-established yung approach? So yun po yung aking ilalatag sa inyo. So JP, next slide, please. Okay, so yung first approach that I will be sharing with you is what is specifically called, like in technical terms, design of experiments, or DOE. So this is essentially a research strategy or method that was invented by a British statistician named Ronald Fisher back in 1958. And then, so essentially this is a pre-planning. Paano mo ba ipaplano yung experimental approach in such a way that you are taking into consideration yung statistical basis of your design. Though itong introduction ko po sa inyo dito sa method na ito, hindi po ako magpapakita ng complex equations on how to calculate things, but it's more of like the mental or the conceptual framework behind this. But then ang gusto ko pong i-highlight dito is that if you learn how to practice DOE, what you can actually obtain as many data points or as many information as possible with a minimum number of experiments. At ito po talaga yung gusto kong i-highlight sa mga nasa atin sa Pilipinas na alam ko na lalo sa high school level or even sa college level, kulang po ang ating resources. So if our resources are actually rather scarce, what we actually have to do is that we have to work smart. Kailangan maayos yung pagkakaplano ng experiment po in such a way that, say, kahit in as small, in as little as, in as few as 8 experiments, you'll be confident na you'll be able to identify an optimum set of condition to get to a particular answer. So yun po yung concept ng design of experiment. So ito yung parang bullet talking points na inilagay ko for DOE. At yung pong process ipapakita ko sa inyo through an example. So if you could actually move on to the next slide, JP.
Medyo magpapasintabi lang ako sa mga participants natin. Medyo we're moving on to the third hour.
Yeah,
So,
medyo
if you
bibilisan ko lang din po ito kasi example
ah,
din to, pero
okay.
feel free
You're
to
free to, yeah, feel
get
free
info.
to get your lunch or get something to eat.
Yep,
And you can always go back kung may ma-miss po tayo dito
yep,
sa
yep, yep.
discussion. Yep.
Opo. Ito mabilis lang po ito kasi dalawang examples lang to. One concept. So yung una ito po case study. For example, if you came up with the research topic say of synthesizing gold nanoparticles for a high school science investigatory project. And then what you actually did was this actually the first could you is wala bang slide before this, JP?
Yeah.
So yun na yun. Ay, nawala yung slide. Okay, it's okay. Okay. So dito po, if the intention of the project is to actually synthesize gold nanoparticles, and then what you did was you went and looked did a research of the literature, and nakakita po kayo nitong established reaction na to. For example, na if you would react gold chloride, gold 3 chloride with sodium citrate, it is one of the suitable routes for you to be able to synthesize gold nanoparticles in a controlled fashion. And then the question is po, yung potential specific research question that you can formulate would be, what are the sets of conditions that would enable you to synthesize the highest to synthesize the high or to synthesize gold nanoparticles at the highest possible yield. Kumbaga, identify nyo yung optimal set of conditions to harvest as much gold nanoparticles as possible. And then upon reading, a bunch of different studies, makikita nyo na yung palang mga variables that you can control that also have influence on the formation of nanoparticles are the likes of temperature, pH of the solution, the solvent that you are going to be using, the concentration of your reactants or of your reagents, and then also, for example, yung ratio po ng inyong gold nanoparticle and with your reducing agent. Because in this case, what's happening is a redox reaction. So, yun po, you have to consider that. And then at the same time, reaction time. Is there a specific treatment where is there a specific length of time na i-conduct mo yung reaction in such a way that you can maximize the yield? And beyond that, wala nang ibang nangyayari. So yun po yung variables, yun po yung inputs ninyo na dinescribe kanina ni Ralph at saka ni JP. And then kapag nandito po kayo sa stage na to, you would know the variables based on what you learned from the literature. But then at the far end of that is you have to ask yourself, ano ba yung output? That's a typo error. Ano ba yung output? Ano ba yung na kailangan mo? Ano ba yung results na kailangan mo? So it's the yield. It could be the size of the nanoparticles, or it could be like the structure, yung geometry ng nanoparticle. Alin ba doon yung mga ita-target mo? So when it comes to these types of questions po, again, we start with a broad topic, and then ang sinabi po namin kanina is you have to keep asking yourself questions and reflect your questions or hypothesis with what's known in the literature. And then you have to narrow it down to the point that yung research question ninyo and your choice of experiment is actually compatible with your resources. So yun po. Alin lang ba dyan sa mga study? And then ilan lang yung maximum number ng experiments na pwede ninyong gawin. So if for example po, magre-rent kayo ng lab at 10 araw lang yung pwede ninyong i-spend dun sa lab, at kada araw, kada kalahating araw, isang experiment lang pwede nyo gawin. So maximum, 20 experiments lang po dun sa 10 days na rumirenta kayo sa lab. 20 experiments lang ang kaya nyo gawin. So ang tanong po dito is, how do you design your experiments in such a way that you can actually get to the optimum condition with the minimum number of experiments? So dito na po ipapasok yung design of experiments. So next slide, JP. Okay, so actually na-flip pala to. So ito yung pinapakita ko po sa inyo kanina na from the broad objective to synthesize gold nanoparticles. You go into the literature and then you look for research leads. Okay, could you go back? One slide. One. Okay, dyan. So yun po, broad topic, you go into the literature and then you actually formulate your specific questions and you look for guides. And then all the way down to meron na po kayong specific research question. What are the conditions that will afford the highest yield of gold nanoparticles? So, and then, could you move forward, JP? And then after that po nun, you reflect. Ilan bang experiments, ano bang variables ang you think are actually most important? So for example po kanina, hindi pa rin, again, meron po dong tayo po dun sa output. Pero stay on this slide, JP. So kanina po, 5 or 6 na variables yung pinakita ko. Pero dito po, based dun sa further study of the literature, it turned out na you can actually focus your efforts on looking at the impacts of temperature, pH, and the ratio of your reagent. So ratio ng sodium chloride to sodium citrate. And then yung output po na desired mo is that yield. Yield lang muna. Doon ka muna magfo-focus. Ano ba yung yield ng gold nanoparticle na nakukuha mo? And then okay. Next slide, please. Okay. So yung typical approach po natin sa high school and siguro sa college, is that yung linear approach lang muna, one variable at a time. Ganun po yung pagkakaturo sa atin. So for example, meron tayong 3 variables. And then, ang tanong, if we're gonna do this linearly, ang tendency po natin, for example, if we're gonna look at the effect of temperature on the formation of nanoparticles, we would keep the pH and also the ratio of the precursors constant. So, constant lang yon sa lahat ng treatment groups nyo to look at the effect of temperature. And then dito po, makaka-measure tayo ng yields at ma-identify natin na, at 50 degrees Celsius pala, doon yung pinakamataas na yield ng nanoparticles. Could you move on to the next slide, JP? Okay. And then, syempre, ang tendency po natin is we're also gonna look at the effect of the other variables. For example po, yung ratio ng gold precursor sa sodium citrate. So what happens here is that, you would, again, set different levels for that variable, keeping pH and yung temperature constant. And then makikita nyo po na, yung palang optimal ratio ng gold to sodium citrate should be at about like 1.5. So, po, if you approach it linear, actually get some hints like one at a time, but then at the end of the day, you know that there's at least 3 very important factors that influence yung pong formation or yung yield ng gold nanoparticles. So if you could you go back to the could you go forward, I'm sorry. Okay. But yung realidad po is yung sinasabi ni Ralph kanina, yung full factorial, meron po kayong 5 levels para dun sa ratio ng precursors at meron po kayong 6 na levels when it comes to temperature. So 6 times 5 is 30. So at the minimum po, para ma-screen nyo po lahat ng potential combination ng temperature at saka ng ratio ng precursors, you at least need 30 experiments. And if ito po ay 3-dimensional plot ng mga potential outcome at makikita nyo po na yung maximum yield makikita mo at about 50 degrees Celsius and 1.5, say 1.5 the ratio po noong precursor. So ito po, gaya ng example ko kanina, kung limited lang po kayo doon sa 20 experiments at yun lang yung kaya ng pera nyo, kung 30 experiments ang kailangan, hindi pa po yun sapat para maintindihan nyo yung effects ng 2 variables, 3 po yung target ninyo. Okay, next. So yun po yung tanong, what if more than 3 variables are involved? So dito na po papasok yung design of experiment. So dito po, again, as a reminder, 3 yung variables, temperature, pH, and ratio ng precursors. Ang ating desired output or result would be the yield. Okay, move forward. Okay, now, so yung concept po ng design of experiment is that you will actually pick experiments that would cover yung bookends po or yung minimum and maximum value, yung range po nung inyong for example variable. For example, when it comes to ratio ng sodium ng gold chloride to sodium citrate, if what you can test is between 0.5 and 2.5, yun lang muna pong dalawang magkabilang dulo ng range yung inyong i-cover. When it comes to temperature, sa halip na mag-i-incremental kayo na 20, 30, 40 hanggang 70, baka po pwedeng 20 to 50 lang muna yung inyong gagawin, or 20 to 70, I think. Yeah. When it comes to pH, sa halip po na 5 values, why not work at like the lowest possible pH that you can implement and the highest potential pH level. So ito po, mahalaga na as early as at like at the conceptualization, alam niyo na, okay, ito lang yung range. So yung magkabilang dulo ng range, yun muna yung aking ita-target sa aking preliminary experiment. And then based off of these well-defined ranges po of conditions or of levels, doon yung po i-build yung inyong experimental matrix. So next slide please. Okay, so instead po na linear lang yung approach, one variable at a time, ang gagawin po natin sa design of experiment, titingnan natin kung ano ba yung potential correlation nitong mga variables. So tatlo po yung variables natin. So if we would assign yung ratio ng precursor sa x-axis and then yung temperature at the y-axis, so again may typo error po doon, yung upper end dapat yung temperature doon should be 70. You would actually have your two-dimensional Cartesian plane po ano. So ito po may x and the y-axis, and then next slide, if you would build a square around it, kita po ninyo na meron kayong 4 sets of combinations wherein you have low values for both the ratio of precursors and temperature, high combination of high and low, and combination of low and high. So ito po, ito po yung minimum 4 different experiments that you should do if you are going to keep, say, the pH constant. But then we know po, yung pangatlo po nating variable, next slide please, meron tayong pangatlong variable which is yung pH. At dito po, nagkakaroon na tayo ng 3-dimensional correlationship. So ito po yung gagawa natin ng mapa. So yung range naman po ng ating pH is from 4 to 9. And so building a 3-dimensional box, or essentially a cube, out of the 3 different variables that you can vary. Again, keeping in mind yung bookends lang po. JP, next slide. What you will come up with is a basic cube po. So essentially, kada points ng cube na yan are covering yun pong minimum and maximum level for each variable. So minimum po, ito, 8 points. Makikita na ninyo, ito na yung lahat ng possible outcomes nandyan sa loob ng box na yan. So in doing so, for example po, yung optimum, yung tinatawag natin optimum result or optimum condition ay nandyan lang po sa box na yan. So by conducting these 8 experiments, mas madali na po sa inyo i-mapa, o dito kapag pala nasa acidic region ka, mas mababa yung pH, baka mas mataas yung result. So paano ba natin ita-transcribe itong cube na ito? Next slide please, JP. So essentially po, parang your traditional 3-dimensional coordinate po, wherein again you assign each variable to each axis to a particular variable po. So wherein yung point A po, doon yung lowest value for yung ratio ng precursor, lowest value for temperature, lowest value for your pH. Pagdating naman po ng point F, yun po yung highest value ng lahat ng parameter. So ito po, ita-translate nyo lang po into yung 3-dimensional matrix into a tabulated form. And then you're gonna populate it po with the corresponding value. So yung point A again is the lowest value for all precursor, for all variables. So yun lang din po, yun yung set ng conditions sa inyong i-implement sa inyong experiments. And then dyan po, by doing so, it is very we can actually assure that it's gonna be much easier for you to identify yung optimal set of conditions. So kung earlier po, yung earlier experiment po, kung linear kayo hanggang po ang inyong maximum yield, kasi yung 30 experiments naubos sa 2 variables. Dito po sa example na to, by doing about like 8 experiments, you were actually able to identify a much higher, you were able to arrive at a much higher result. So dito po, makakakuha rin po kayo ng correlation. No? Hindi ko po gagawin yung hardcore mathematical modeling kung ano ba yung relationship ng ratio ng precursor sa temperature at sa pH. But then, ito lang po is more of like conceptual guide na this is the level of rigor na minimum set ng experiments po for you to be able to identify the optimum set of conditions or the optimum set of variables for you to actually get to the optimal result. So yun po. Yung concept po ng DOE is that yung minimum number of experiments po is equal to m raised to the n, wherein m is the number ng experiments that you are carrying out per variable, and then n is the number of variables. So in this case po, yung sa ating bookends kanina, so minimum and maximum, so dalawa lang pong experiment per variable. So 2 raised to the n. Tatlong tayo, so that would be, yun po yun ang form ng ating cube. So next slide, JP. Ayun, yun. So pinakita ko lang po. So definitely po, kapag apat na yung variables, so 2 to the 4 na po yan. So mas palaki po siya ng palaki. So ibig sabihin po, may mga slices kayo dyan sa cube. And then kung titingnan nyo po itong cube natin, yun pong surface ng cube na nakaharap po sa atin, yun po yung, again, set ng experiments that you would do at a constant, what they call this, at a constant pH at pH of 4. Yung kabila naman pong dulo, those are like the set of experiments that you will be doing at a constant pH of 9. So essentially po, pinopwersa po ninyo, kino-constrain po ninyo yung outcomes within the bounds of your conditions or of the levels of your variable. So ito po yung isa sa mga approaches kung paano po ba ninyo ma-minimize yung number ng experiments but still get like some meaningful results. But then again, yung pong variation kasi minsan ng effects na yan, yung dependency po kasi minsan ng ating results sa ating controlled variables, minsan po hindi yan linear. Ano po, minsan yan ay it could be exponential in nature. So dapat po, pag alam nyo na yung yield ng nanoparticle mas mataas kapag mababa yung pH. So kapag po nag-optimization na kayo, alam nyo na doon na kayo magsistay doon sa acidic pH. So pH of say below 7. So pag nag-optimize kayo, mas focused na po ang inyong sets of conditions. So yung probability ninyo to get to a better result is mas mataas na kasi hindi po kayo kalat. Mas focused na po yung narrower na yung set ng inyong condition. So this is how you actually start doing your preliminary proof of concept din po. This is how you prove that like your hypothesis is actually meaningful or it can actually it is verifiable by your experimental data. And that is again DOE. So sabi ko kanina, kung 20 experiments at by doing DOE, 8 na yung nagawa nyo at na-identify nyo yung optimum. So definitely, meron pa kayong 12 experiments to optimize. Yun, para mas maging solid pa yung inyong experimental result. Baka pwede pa kayong mag-study. Ano ba yung mechanism behind this? Ano ba talaga yung fundamental scientific interaction between the solvent and gold? Pwede pa natin siyang i-improve. So yun po yung pwede natin gawin. So again, just because the resources are limited doesn't mean that we cannot do anything. You just have to be able to work smartly. Yun po. So ito pinapractice po ito ng mga scientists abroad. So yun po. So ito po yung gusto kong i-introduce rin po sa inyo. So kung paano ba sa sisimulan in such a way na baka pwede tayo makapag-level up dun sa linear approach sa isang variable lang at a time. Kasi minsan though it's systematic and it could actually give you like fairly clean results, ang problema po kasi na minsan sobrang bagal at limitado lang din po ang inyong masasagot. So ito po, this is kind of like trying to push the envelope by using these systematic tools or approaches to things. Yun po yung design of experiment. Okay, next. Okay, so gusto ko lang din po i-share sa inyo, ako po practicing scientist ako and I'm actually quite fortunate po to have a fairly prolific research career. So ang dami ko pong invention, ang dami ko rin pong mga scientific publications. But then yung question po kasi is, if someone like me, na full-time po na scientist, kapag po ba ako ibinigyan ng challenge ng aking bosses or ng kumpanya ko saan ako nag-work, usually po ba yung mga tanong na yun, alam ko na agad ang gagawin ko. Minsan po, sa totoong buhay po, ang mga scientists po ay normal na tao din po. Hindi po lahat ng bagay alam namin. Hindi po sa lahat ng pagkakataon na kapag challenge kami, alam na agad namin yung gagawin namin. At may pagkakataon po, kahit magbasa kami ng magbasa, mahirap po talaga mag-formulate ng approach kung walang precedence, kung medyo uncharted yung territory, wala kang prior literature. Ang tanong, paano ka magsisimula? Paano mo siya gagawin? So minsan po, you just have to come up with the brute force, you have to resort to brute force approach para po makakuha kayo ng result. So ito po, dito ko po ipapasok yung tinatawag natin na accelerated serendipity. So yung serendipity po, yung definition niya sa dictionary, it's an aptitude for making desirable discoveries by accident or good fortune or luck. Yung ibang definition po na nagustuhan ko sa isang article that I found online was, it's an unsought, unintended, and or unexpected but fortunate discovery and or learning experience that happens by accident, or a combination of events which are not individually beneficial but occurring together produce a good or wonderful outcome. So ito po yung para kung sa exam chamba, parang ganyan. So nagla-line up yung stars para mangyari yung bagay na yun kahit hindi naman pupilano. Randomly pinagsama-sama mo yung iba't ibang materials and you ended up building something that building an invention. So yun po yung tinatawag natin na serendipity. So ano ba yung term na accelerated? So yung accelerated serendipity po is, since again, admittedly, karamihan din po ng scientific discoveries ng mga sikat na scientists happen by accident. But then the question is, how do we actually push ourselves to run into those accidents? Paano ba natin papataasin yung frequency nung ganong accidents? Paano ba natin papataasin yung probability natin na pagpunta natin sa lab, pag naghalo-halo tayo ng certain chemicals yan, we're gonna be able to come up with something. The key to that is, again, sabi ko, probability, population size. So, ibig sabihin, mas dadalasan mo yung paggawa nun. Dadamihan mo yung experiments na gagawin mo kung hindi mo alam kung saan ka magsa-start. So, yun po, for certain institutions po or groups, for example, you have the luxury of time to do, say, 100 experiments. Yun po, you can actually come up with, you can resort to accelerated serendipity. Hindi po, minsan po talaga darating kayo sa puntong hindi ka makapagplano ng step-by-step approach for doing this. So for example, may nakita akong halaman sa gubat na, itong halaman na to, sa lahat ng mga katabi ng halaman siya lang yung hindi kinakain ng mga uod. Or so, for example, perhaps it has some pesticidal properties. But then the question is, how do you extract the pesticidal property? Hindi kilala yung halaman, hindi mo alam yung tamang approach for doing this. But then, kung pag-iisipan mo, ano ba yung typical factors or techniques na ginagamit para ma-extract yung mga bioactive components? So, do you use a solvent? Kailangan bang gilingin mo yung halaman? Kailangan mo ba siyang initin? Those types of techniques and potential variables that you can control, minsan po, you just have to list them down kahit hindi mo alam yung interaction ng mga variables na yun. And then, come up with experiments where you are combining or probing a couple of variables at a time, and then look at the level of the result that you're getting. So, ito po yung tinatawag natin na screening stage po. So, wala pa tayong ina-expect na optimum result. We're just doing all these experiments to hopefully run into a very good outcome. So, yeah. Okay, so for example po, babaguhin naman natin yung sitwasyon sa gold nanoparticles. So for example, ito po hypothetical lang for all intents and purposes. Paano po kung halimbawa, na-assign kayo, you have to actually come up with a technique to synthesize gold nanoparticles. And what happens is, walang prior literature na nagbibigay ng hint kung ano ba yung mga reaction na pwede nyong gawin, ano yung sets of conditions na dapat ninyong i-implement sa inyong experiment. So, how would you actually start? How would you identify a synthetic, or how would you come up with a synthetic protocol, and how would you identify a set of conditions that would maximize the production of gold nanoparticles? So, dito na po papasok yung accelerated serendipity. Okay. Next. Yeah. Okay. So dito po, kung atin po uling titingnan lahat ng mga variables possible. So you have your reactants, you have your temperature, you have your pH, reagent ratios, solvents, concentration, catalyst if needed, and then time. So napakarami po niyang variables na yan. But then at the same time, po, hindi niyo alam ano ba yung relationship ng mga yan at ano yung influence nun sa pag-form ng nanoparticles at anong influence nun sa yield ng gold nanoparticles. So next slide. So what you do po is ang dami ninyong potential variables. What you have to do is you have to prioritize. Kasi again, limited ang resources. Ano ba dun sa mga factors, ano ba sa mga variables na yun ang pwede ninyong, ang dapat nyo unahin. So, if I were a chemist po, ang unahin ko dun is yung reagents. Ano ba yung mga precursors na kailangan kong paghaluin para makaform ako ng gold nanoparticles? And then, on the side po, ano ba yung mga critical conditions or parameters na dapat kong tingnan? So, pwede po kayo magbasa sa literature. Ano ba, meron ba siyang related reaction using other metals, perhaps like for silver, pag-form ng silver nanoparticles, baka pwede tayong kumuha ng inspiration doon. It turns out po, for example, dito, we're prioritizing pH, solvents, and ratios. And then again, ito po, meron ako dito mga nilagay na potential levels. But then again, at the same time, ito po, wala kang guidance from the literature. So, it could be that the optimum condition is outside of the scope, but then you're just using these arbitrary levels to actually downsize your set of experiments. Okay, so how would you approach this? So like I said, you have to prioritize po. At kung ako, kung nasa high school level ako at ipa-prioritize ko, alin ba dito sa mga factors na ito ang una kong i-investigate? Para po sa akin, on a cost perspective, mahal ang gold. Mahal ang gold precursor. So definitely, kailangan kong maintindihan alin ba yung gold reagent na kailangan kong gamitin. So doon po ako magsisimula. GP, next slide please. Okay, so what you can actually do is come up with an experimental matrix. So essentially po, meron kang gold precursors, meron kang organic reducing agents. So ito po, these are hypothetical examples po. Huwag niyo po itong kokopyahin at huwag niyo po itong iperform sa lab. Ano po, this is just for demonstration purposes. So what you do is you set a constant temperature, pH, and you just use one solvent for doing this screening. But then ang goal po is for you to figure out alin dito sa mga combination na ito ang magbibigay sa inyo ng pinakamataas na yield ng gold nanoparticle. So it turns out po, could you click on the next thing for the animation? Okay. So yung pong size ng spheres dito is proportional to the yield. So ang gagawin niyo po dito is alin ba yung nagbigay sa inyo ng best outcome? So for this particular screening, yung combination po ng gold chloride with sodium citrate or citric acid, yun yung nagbigay ng best result. So definitely, yung ibang pair up, pwede nyo na muna po siyang pwede tanggalin yun sa pool. So definitely ngayon, instead of meron kayong 3 choices for gold precursors at 4 na choices for the reducing agent, what you're left with is actually just like a pair, like two potential combinations. Okay, next. I'm sorry, I think like my mom is calling. Yeah. Okay. Did you move on to the next one, GP? Okay. Okay, so ito po, yun, na-prioritize na po natin. We're actually, instead of having 7 chemicals in consideration, we're down to actually just 3. And then now, what we can actually do is then we can start looking at the effect of the other variables. So next slide, please. Okay, so ito po, ang ginawa natin is, yung outcome ng pink is, for example, the combination of gold chloride with sodium citrate, and then yung second naman po is gold chloride with citric acid. And when we did the same experiment, varying the temperature and the pH, what we notice is that, next slide for the animation, is that the highest yield or yung highest production ng gold nanoparticle can be obtained from gold chloride and sodium citrate at temperatures of 70 to 100 degrees Celsius. So definitely, as you do more of these screening experiments po, nananarrow down po ninyo yung range ng inyong variable. So this is actually how you do accelerated. This is actually how you do like accelerated serendipity. So ito, you're doing a lot of experiments, but in the process of doing it, you're actually getting rid of other potential candidates kasi nakikita mo alin ba talaga yung gumagana. So this is again like a deductive way of figuring out correlations between variables. So by coming up with all these campaigns, and then what's gonna happen po after this is that when the range of variable has actually narrowed down. So for example, ngayon yung temperature, alam niyo na between 70 to 100. Yung alam niyo na mas better yung gold chloride plus sodium citrate. So at this point po, narrow down na. Alam niyo na isa na lang pair up ng precursor ang kailangan niyo. Alam niyo na kailangan acidic, yung pH is equal to 4. Dito, at this point, pwede na kayong maggawa ng design of experiment to optimize. So that's actually how you start an experimental campaign, by screening a very broad scope of variables and levels of those variables to the point that you can actually start seeing correlation. Again, yung formation ng gold nanoparticle pala ay favored in an acidic medium and at a fairly high temperature. And that's actually it. Pwede na kayong mag-optimize. So yun lang po yung approach. Sometimes, okay lang kung hindi nyo alam yung okay lang kung hindi sobrang specific agad yung approach. Minsan po talaga kailangan pagdaanan to. This is what we call the proof of concepts stage. And then essentially you are removing as much you're simplifying, you know, like your understanding of the specific scientific phenomenon by figuring out like how these variables are actually interrelated and how they affect the results. So yun po. And then lastly, going back dun sa last slide ni JP, ito lang din po yung i-reiterate ko sa inyo. So when it comes to designing experiments, again, you have to be able to formulate a sound research question. And how would you actually be able to do that? You have to keep reading the literature, refine your question to the point that you'll arrive at a specific set of research objectives. Ano ba talaga yung specific na question na gusto niyo sagutin? And paano niyo malalaman kung specific enough? Specific enough kung ang sagot doon sa inyong objective or specific research aim ay yung specific experiment, yung specific technique na gagamitin niyo. So that's actually how you come up with the design of the experiment. So again, what we focused on this webinar is more on the conceptual framework behind designing hardcore statistics approach that will come as a separate offering. But then yun po, I will leave it at this po. So medyo nagtagal po tayo, but maraming salamat po sa lahat ng mga tumutok. Pwede po kami mag-entertain ng tanong if you still have like questions. Maraming salamat po uli sa inyo.